Hello everyone. So in the last video, we talked about a very basic electric circuit. And before we get into more complicated circuits, I want to take some time to talk about different electrical components and generally what they do and their schematic symbols and all of that. So the simplest component is uh, a resistor. And typically that's the symbol is like a little squiggly line. That actually was not very good, I have to admit. Let me just resketch this. That looks a little better. It basically a zigzag line. And essentially what a resistor does is it simply converts, when there's a current flowing through it, it converts the energy into heat. So it doesn't really, you might think to yourself, well, like, how is this even useful? Um, but actually, there's a lot of useful things that you can do with resistors. So for example, if you light up an LED, it turns out that LEDs can be easily damaged. And so you usually want to add a resistor to an LED to keep it from burning out. And so that's like one use. Another use or to think about is sometimes we actually want heat. I mean, think about an electric oven or a toaster. That essentially the wires that are inside like a toaster are essentially resistors. And so as current flows through them, they generate heat. Another component that you'll definitely see in this course is a capacitor. And I would encourage you on your own time just to Google these things, resistors, capacitors, so you can get an idea of what they actually like look like. Um, but these are like the schematic symbols. And we'll talk more about capacitors, but essentially they're like devices that can store electric charge and then quickly release it. So for example, a flash on your camera will most likely use a circuit that charges up a capacitor and then dumps it really quickly. So it's kind of like a battery, but it's typically meant for not like powering things, but more just like quick bursts of energy. They're also used for things like filtering radio signals and things like that. So there's tons of uses, and you will learn more about that. Um, so there's resistors, there's capacitors. Um, there's also we can talk about voltage sources, or actually, you know what? I missed something here. We should also talk about inductors. The symbol for an inductor is this. And these are useful for all sorts of things. They're uh, used to filter certain electrical signals and things like that. But we will talk more about that and the uses. But for now, you can know that that's the symbol. But we won't be dealing with inductors until later later in this course. Um, so another really important component is basically a voltage source. We talked about that already, but essentially it supplies a continuous source of electric potential difference or voltage. And we actually call this an independent voltage source, meaning that it always outputs the same voltage no matter what's connected to it. However, you will encounter in this course what we call a dependent voltage source as well. And there's a way that we can build these with an electronic circuit, but for now we'll just talk about what it does. So we call this a dependent voltage source. And essentially, instead of the voltage being constant, it will be dependent on something else. Like it could be dependent on a different voltage in a different area of the circuit. It could be dependent on time. Generally, it's dependent on something else in the circuit. So, for example, we could say the voltage is equal to maybe 2 times I1 or something. And I1 would be like some other current in some other circuit that's controlling this source. So you can change it essentially. So these will show up in this course. But essentially the voltage across this dependent voltage source is dependent on this other variable. Whereas in this case, it's independent. It's always constant voltage. So in addition to voltage sources, another, here, let me go ahead and move this. So some other components that you'll want to be aware of is current sources. Just give me a second here. Okay. So a current source, the symbol for that is this. And it's similar to a voltage source, but what it does is it will output a constant current no matter what's connected to it. So you could connect any resistor, and what it will do is it will automatically produce the voltage that it needs to make in order to keep that current constant. You can also have a dependent current source, so something like this. And so then I would be equal to some kind of variable. Again, I could say just 2 times I1 as an example. And so this current then, the amount of current that it outputs would be dependent on some other variable in the circuit. So yeah, the voltage sources, those are like having, constant potential difference. The height between those 2 tanks in our water analogy is always the same, no matter what the current flow is. In the case of a current source, it's like the height of the 2 tanks will adjust itself automatically so that the current is always constant, no matter what you connect across it. So that kind of summarizes the different components that you'll see in this course. From here, we can begin to start thinking about more complex circuits. So I will see you in the next video. Thanks. Hello, everybody. Thanks for watching. If you found this content helpful, would you please consider liking and subscribing to the channel? That will help other people find it. And if you won't do it for me, will you do it for my cat, Muon? Named after my favorite subatomic particle, by the way. So she will be very, very upset if you do not like and subscribe. So please, don't disappoint. How could you say no to this cuteness?